There, that way you have a recording of this later. And Scott, I'm going to set my screen to share screen.
Sure.
No, I'm pressing the wrong button. I'm going to enable you to share screen. And you should be able to take control of the class and the lecture now.
Does that work?
I got Scott Melnick has started screen sharing, but just the black. Oh, it's going.
That's better?
Yeah, house on fire.
Perfect. And my audio is good? You can hear me good? Great. All right. Hi, everyone. As Murray said, I am his grad student. And I'm going to take you guys on a tour of the Kootenay Plains region. It's a region that I'm studying as part of my PhD and that Murray is also quite familiar with. Just to kind of start off, we're going to look at some really old rocks. They're some of the oldest rocks in Alberta, which makes it particularly cool. It lies between Jasper and Banff. Here's Banff and here's Jasper here. So it's kind of a hidden gem in that respect. It's a little bit tucked away, harder to get to. So it's definitely less traveled, which makes it cool. So basically, if you're coming in from Alberta, you'll be coming in through Rocky Mountain House. There's really only one way to get into this area unless you're already in the mountains. So you'll be coming in from Rocky Mountain House and you're gonna drive along the David Thompson Highway. And that's kind of what we're gonna do. We're gonna take a roadside trip along this highway and just point out some of the geologic features and some of the more cool and relevant tourist attractions as well. But before we start, I just want to give a little background. This area actually there's been a lot of talk about this area because in 2018, it was proposed as a provincial park by the NDP government. And then when the government changed hands, the UCP government, for better or worse, kiboshed that idea. So it's really unique in that it's really accessible to people and there's not as many restrictions, which makes it cool in that way. And a lot of outdoor enthusiasts love this area, like hikers, backpackers, climbers, fishermen, equestrians, of all types, really. So the first thing we're going to look at before we actually get into the mountain ranges, I'm going to show you guys Crescent Falls, which is a couple waterfalls that are situated along the Bighorn River here. And they're not actually part of the succession we're going to look at today, but it's interesting nonetheless, so I thought I'd show you guys. If you're in the area, this is definitely a must-see. So this is the view from the top of the falls. You can see a nice Cretaceous-aged rock formation here, and these darker bands here are deeper marine mudstones, and these lighter bands are shallower marine sandstones. So this whole section is a series of stacked marine deposits. Just a view upstream a little bit. Then we'll go, I guess I better go present view. And we'll just go down to the lower falls here. So this is just a photo. It's a pretty nice photo. It shows you how beautiful it can be during the winter time. Not a lot of people go to see sites during the winter, but this is definitely one that you could go visit. And if we take a view from a little bit further back, oh, sorry, for some reason. So as we go further down along this tier here, we see the second set of falls and we see more rock exposed here. And what's cool up here is that you can really see that these layers of rock around this amphitheater, they all connect. You see, so you can kind of envision that at one point these rocks were continuous throughout where we're standing. And they have been cut through time to give this sort of really amphitheater-like feature. It's really cool. And what that means is that where we're standing is kind of like an ancient seafloor. And then when we look at our feet, we can start to see these etchings in the ground here. And these are a lot of different trace fossils. And when you start to look at them, you can see little patterns in the rock itself, like these paired openings here. And what these are openings on the ancient seafloor, or when it was modern. And these tubes are connected, or these openings are connected with this U-shaped tunnel, and organisms burrow inside and live in them for food or to keep safe or what have you. So that's just a cool thing to look out for if you are in the region. And then just for completion's sake, going down to the lower end of the falls here, those two tiers here, and it drains out this way. And when we look at the ancient seafloor here, we see these linear features here, and these are ripples, or fossilized ripples. So basically, these were formed by current flow over 100 million years ago. And because they're lined in this direction, we know that the paleo current had to be flowing perpendicular to that. So that's just another cool thing to point out. And now as we get more into the main ranges, or the front ranges, the first thing that we see is Lake Abraham. And this is a spectacular lake. It's actually a man-made reservoir, the largest reservoir in Alberta. And admittedly, this is a filtered photo, but the lake really is this blue. It's really a spectacular blue. And that blue is from rock flour. I'm not sure if you guys have talked about rock flour. It's basically, it forms as glaciers abrade and polish fine-grained sediments, and then they eventually make their way to the lake, and then they reflect the light, and it makes that beautiful color, which is common among a lot of lakes in the mountains. Another feature that's cool in this lake is that during the winter months, when the lake freezes over, there are organisms, or bacteria, I should say, that feed on organic matter in the lake. And when they consume the organic matter, they give off methane. And they form bubbles that pool up underneath the ice surface on this lake. Unfortunately, I couldn't find a photo of that. But after this lecture, a quick Google search of Abraham Lake methane bubbles is pretty spectacular. And as the ice thickens, they kind of form these stacked layers of these bubbles. So it's kind of like a 3D architecture of bubbles. So it's pretty cool. And here is basically the first set of real rock that we see as we come in. This is called Windy Point. It's a very good lookout spot, and probably more importantly to us contemporary tourists, it has a little bit of service. It's about the only place that you're going to find cell reception in the area. So that's another tidbit. So moving along, the next thing we're going to see is just to quickly show the David Thompson Resort. This is really the only commercial spot in the area. It's got hotels or motels here, a full campsite back here, a pretty vintage playground, and then you got your convenience store, gift shop, and restaurant in there. But just to show you guys that it is here. And if you are staying out there, there's a trail that goes down to the lake. You get a little private viewing of the lake, which is quite nice as well. And if you want to spend the money, you could also go on a helicopter tour of the area. I'm sure that would be fantastic. But as we pass Lake Abraham, we get to a hike that is pretty family friendly. The trail's pretty nice. You can actually see the full trail on Google Earth, but there's not too much geology, so I won't go too far into it. But yeah, it's a few hours of a hike. I'll take you guys to some of the more scenic spots just really quickly. This is my favorite view of the hike. It's just a nice view of the gorge here, just right beside the falls. And the falls are right here. So that's Siffler Falls.
Oh, so that's the Siffler Falls hike. Oh, okay. Yeah.
Yeah.
Okay. Yeah, that's a gooder.
Yeah. So next we're gonna visit 3 roadside outcrops, just to see some of the geology that's really accessible from the road. This first unit we're gonna look at is Lower Cambrian Motto Formation, so it belongs to the GOG group. It's dominantly sandstones, a little bit of dolomite in here as well, but this is shallow marine deposition. And as we move up section, we get into this green siltstone and fine-grained sandstone unit. That's the Mount White Formation.
That's right.
So actually within this outcrop,
we just that one the other day.
Sorry?
We just reviewed that one as part of the Cambrian stratigraphy on Monday.
Oh, really? Oh, perfect. So I don't have to go too far into it.
They know the GOG group, they know the Mount White, theoretically.
Perfect. Sounds good. So yeah, right in this outcrop, you can see the transition from the Lower Cambrian GOG to the Middle Cambrian Mount White. And if you do stop here, you can look in this outcrop, and there's bits of trilobite and various trace fossils that you can try to spot. A little bit down the way, we're going to go to the Cathedral Formation. This is another Middle Cambrian unit. This is another one of those cliff-forming carbonate units. And this, unfortunately, this is around a bend, and the shoulder is very narrow, so I actually wouldn't advise stopping at this location, but taking a look as you drive by is quite cool to see the zebra dolomite, which I'm also told you guys have talked about.
Oh, and there is a good pull out there. If they keep their eyes peeled, there's a couple good places to pull out a couple of 100 meters before and after the outcrops. So there's easy access, but you do have to walk in the ditch.
Perfect. And then the last one I'm going to just show you guys is particularly cool because it is Proterozoic. So it's really old, probably over 550 million years old. I'm not actually sure the exact date of this, but this is the Wind Formation, part of the Mayette group. So it starts off here with these metamorphosed mudstones. We call these peelites. And then here it's more sandstones, but you can also see some mudstone interbeds. And this is actually a section of turbidite deposits, so deep sea density currents, or deeper sea density currents. And that's the last roadside stop. I kind of wanted to end the roadside tour just by showing you guys Landslide Lake, the trailhead here. If you go in here, there is a bathroom, which is important. And there's also an interpretive loop, like a little family-friendly hike that you can go, that there's information on signposts about the area and the controlled fire that was set in 2009 to help maintain the area. A lot of cool information in there. And if you want to, and if you're able, there is a hike to Landslide Lake that is quite a climb, but I'll show you guys here. So the loop that I was talking about is in here somewhere in this forest. And if you continue along this ridge and up through this pass, you make it to Landslide Lake here. And if you Google Landslide Lake, the $1 million view is pictures right from the top of this high pass here. But the climb is really, it's treacherous. I think it's over 1 kilometer. I think over 1,200 meters actually. So you do need to have some endurance to do that. But luckily we were able to find a photo of the area. And unfortunately not of the high pass, but we can see at the lake here. So we came in from this area here. Unfortunately we can't see that, but it's just a spectacular area, really quiet, kind of backcountry area. And if you continue along here, it joins a network of backcountry trails and another series of lakes that you can visit. Fishermen like to come here. Some of them get helicoptered in, which would be quite the experience. I'll just take you to a second lake, a smaller lake called Lake of the Falls. In my opinion, equally beautiful. And yeah, I think that's pretty much it. That's kind of my plea to visit this area before it gets too restrictive. So just to orient you guys again, we kind of came down this highway, stopping along the way. here is that Siffler Falls hike that I was showing you. Then we visited a few outcrops along this stretch here. And here's the Landslide Lake trailhead. Here that you can see this little loop here if you want to take your family out for a stroll, or if you want to go all the way back into the backcountry, you can go past this high pass and join this network of trails. You can also enter from this location here, or if you have two vehicles, you can park one here and one here and you kind of can do whatever you want. But yeah, that's pretty much all I had to say. Murray, do you have anything to add?
No, that's fantastic. You might want to mention that there seems to be an anomalous numbers of bears in that area year to year.
Yes, very dangerous in the way of bears.
Yeah, it's not for solo hiking at all. Like I wouldn't hike there alone. Always in groups of 3 if possible, I think. But yeah. Any questions from the group? Scott, one thing that we were discussing on the chat here is sharing the KMZ of your tour and some of the tours I've done. So I think you can export from Google Earth there a KMZ file. If you can email that to me, I'll test it and then circulate it with the students.
For sure. Yeah.
That is if you're willing to share your favorite spots with them.
Yep, that's what I'm here for.
Okay, that sounds great. All right, I'm still watching for questions. Okay, you got 10 seconds. 9, 8. Okay, Scott, you're a free man. You can sit in on the rest of the lecture, or you can go hang out and, I don't know, watch some Netflix or whatever it is you PhD candidates do for a living.
Sounds good.
Okay.
Yeah, talk to you later.
Right, thank you.
No problem.
Yeah, you got a lot of thanks coming in. There's thanks from Angus. So
Yeah.
there you go. Oh, yeah. Yeah, that's great. Margaret's going to share some pictures of her adventures in the Nordegg area on the Google Drive, everyone, so you can watch for that. All right, I think it's time for me to start doing my job again. And so to do that, I think, Scott, you'll have to stop sharing.
Oh, yes. Okay, there we go.
All right, that's good. I'm going to go to tile view. Okay, everybody's back. I'm very pleased with the turnout today. We're going to pick up on the Cambrian where we left off last day. And as such, we'll go back to the notes. We were right around the Stephen Formation and the Burgess Shale. Certainly one of my favorite rocks. All right. So I've just gotten to the point where I was going to introduce you to the Stephen Formation, which is stratigraphically just on top of the Cathedral Formation and just underneath of the Alden. The picture above right is the Alden Formation overlying the Stephen, overlying the Cathedral. The image on the left is a siltstone from the Stephen Formation. Not really a shale or slate, but a siltstone, but never mind. It's a shaly siltstone, whatever. And then some body fossil from the Stephen Formation shown on the lower right, an early type of arthropod. And then an arthropods being things like trilobites, shrimp, crabs, insects are arthropods, but this is among the first, okay? Almost everybody has heard of the Stephen Formation. The Stephen Formation, as you know it, is probably known as the Burgess Shale, and most people have heard of it because it keeps showing up in the news almost on an annual basis. There's some type of new discovery or new evolutionary insight or new insight about the early Cambrian biomes and the first assemblages of animals. And shown on the left is a whole bunch of pictures from a paper that was published just a few years ago on an animal called Anomalocaris, a truly weird looking animal that is actually exactly what we're seeing. I think this, yeah, that looks like Anomalocaris right here. Whoops, why isn't my pen working? What's going on? Right there. And I'm going to take you on a little personal trip down memory lane. I started my undergraduate in geology actually at the University of Alberta in 1991. And I took my first geology class with Professor Roger Morton, but then back then we had 2 introductory classes, and my second geology class was called Geology 103. They weren't called EAS back then, but GEOL 103. And Richard Fox, who was a paleontologist, was teaching that. It was about the world through time. Now, you notice I said I started my undergrad in 91. Well, that book, Wonderful Life by Stephen Jay Gould, at the time, an extremely famous Harvard paleontologist, one of the researchers who, during his PhD work and shortly thereafter, really changed the way we viewed evolutionary processes, the mechanisms by which they occurred, and at what rates and how they occurred, some fundamental aspects of evolution that were requisite. Oh, right, that does look like a Eurypterid, doesn't it? Well, don't worry, we've got good pictures of Anomalocaris coming up. Yeah, you can see, you can't see these cool little claws near its mouth here on the left. Anyway, right, back to it. So Richard Fox was my professor in January 1992, and he started going off about this book that had recently come out called Wonderful Life, that was written by Stephen Jay Gould, and it's fantastically written, and it's a wonderful viewpoint on the distribution of animals that are actually present in the Burgess Shale fauna and what their evolutionary significance was. And it waxes poetically. Stephen Jay Gould was a really interesting paleontologist. Worked at Harvard. He was an American by birth. And what he decided to do after he finished his PhD, I mean, if you guys, if this class, if this group, if all of you people have been in university long enough, you'll know that quite often your professors are a little preoccupied with the idea of publishing papers, right? And especially if you're in science, medicine, or engineering, in those fields, we're very much obsessed with the concept of getting work published. And there's a variety of reasons for that I don't really need to dwell upon. But Stephen Jay Gould decided fairly early in his career that he wasn't that into writing papers. And he decided to write an essay every month that related to science or natural science, geoscience, or paleontology. And ultimately, he brought several volumes together, and he published these essays by theme. And there were many wonderful books that he published that are well worth reading, and they're written as scientific prose in a way, but it's light and it's tractable and it's interesting. Wonderful Life is his view of the Burgess Shale and how it should be interpreted through the prism of evolution. And I think since then, a lot of the ideas that he puts forward in the book, which is the Cambrian explosion in particular. What is the Cambrian explosion? This idea that there was an assemblage of animals that are represented by the Burgess fauna that represented this early stage of animal life on the planet that, for various reasons, mostly because of experimental designs and lack of competition, exploded in this range of morphologies. Many of these ranges were dead ends, Stephen Jay Gould suggested, and many of these animals represented what we call stem phyla for later life. Why stem? Because the branch of the tree of life branches out. The stem is where it all starts, right? These are the various stems, the first polychaetes, the first mollusks that develop shells and so on. anyway, some of that view's changed, but we still view the fauna of the Burgess Shale as 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 being emblematic of the Cambrian explosion. And there's actually a few sites now. I think I have the picture here. Yeah, there's a few sites that have shales that are fossiliferous with animals in it in a few places around the world. This is a reconstruction from paleo, basically a paleotectonic image of the Cambrian, and it shows the distribution of Siberia, Baltica, Laurentia, and South China. And these are all Burgess Shale locations in fauna, with the oldest actually being in South China now. It's a few million years older than the Burgess Shale. And if we wanted to look at just an example of the Burgess Shale fauna, we can look at Anomalocaris canadiensis. This paper was done by Alison Daly and Greg Edgecombe. Greg Edgecombe is basically he's very prolific in Burgess Shale research. And Greg Edgecombe really, he's a fine paleontologist, but he has kind of a monopoly on the whole Burgess Shale business too, right? And so he's definitely leveraged a brilliant career out of that. Greg Edgecombe is a pretty brilliant worker, though, and I think nowadays he's in Australia, but I heard he might be moving on. And anyway, there's the morphology of Anomalocaris canadiensis. And here's some fossil materials. And I think the left-hand image shows you why the Burgess fauna are so important. It's mostly soft-bodied material that's preserved. You might not appreciate it, but probably 99% of the fossil record is, at least of the body fossil record, is skeleton, okay? It might not be skeleton like you or I have, a spine and femurs and long bones, but for example, you could think of the shell on a gastropod as a skeleton. Those things are great. They're hard. They fossilize readily. They're already mineralized. So sometimes going into the rock record even enhances their mineralization. But with soft-bodied fauna, that doesn't normally happen. If you just throw a worm into the ocean, it's probably not going to end up being a fossil. It's just not likely. Well, these are all soft body parts, and you can see how nice the preservation is. And the preservation is because there's been a mineralization associated with the animal flesh, and that mineralization made for a very interesting clay mineralization film that passed into the rock record and turned out to be exceedingly durable over time. And so you get these wonderful preservations, and even this lower part of that fossil, that's part of the flattened body, I think. Yeah, it is. It's part of the flattened carapace. Let's look at some other bits here, just some other examples. There's something paleontologists like to do. They take a messy fossil like you have on the left, and then they draw sketches of it and they label it all up. The L's are lobes. Those are some type of carapace or flesh lobe on the side, and then there's tail bits and whatnot. And then you can see these other aspects of it here. So just other views of the fossilization of Anomalocaris. And there's a bit there that shows the mouth parts, right? It's got these kind of things that look like shrimp coming out of its head. And those shrimp-looking devices are actually jaw bits that can clutch food and stuff it in its mouth. Very, very fantastic. Gotta love that animal. And then just some more examples of the excellent, exquisite preservation. So I actually put this paper for you on eClass. It's shareable on eClass. And I'd certainly emphasize that I wouldn't examine you on any contents of the paper, but if I asked you what Anomalocaris is, a good answer would be a Cambrian aged animal found in the Burgess Shale. It's really famous for that. And then I'm stretching my memory trying to remember if there were actually a schematic of the animal itself. There's great photos of Anomalocaris on the Google anyway. So I'm going to close this paper. Any questions so far? The Uba predator of the Cambrian. It really is, for sure. Oh, I don't need to. Wow, that's fine. Right, so we're not going to do that yet. We still have some Cambrian rocks to do. So these are the locations of the Burgess Shale. And the Burgess Shale really is a fascinating rock unit. You can go visit it yourself. And I think to that end, we're going to go on my Google Earth tour here. So just stand by and look at some locations for the Burgess Shale. Mm-hmm. Move that there. Move that there. Sharing screen time. That's it. I like it. I think last time we went hiking, before we went hiking with Scott, we'd actually visited Pyramid Mountain, and then we had taken this Google tour over to Walcott's Quarry, which we'll do now. I love these mountain views. This is kind of looking along the strike of the rocks. You can see the crests of the mountains going linearly away from us. And Walcott's Quarry is pretty high up. When you think that this was discovered in the, Walcott's Quarry, probably the late 1800s. It's fantastic. They were getting up and down this river, mostly by horseback, and then they were climbing up those mountains with decidedly low-tech gear, like leather boots, waxed cotton jackets, and backpacks that weighed 48 pounds empty and probably weighed 148 pounds full. I mean, good Lord, those people must have been tough, hey? And then let's go. So I mentioned that you can do these guided tours of the Burgess Shale, and they're actually, I heartily recommend these. You got to be in good shape. It's 22 kilometers in and out total. That's big. And the thing is, though, it's high. This is like a 700-meter up hike. So this is getting to the point where it's, I mean, for sure, really good climbers, that's nothing. But to the average person, this is a hard hike. And it's worth the money because the guides are actually really good. And one thing they do that's hard to replicate on your own, you can't go to Walcott's Quarry by yourself anyway. That is guided tour only. But they've stored hundreds of fossil examples up there. So if you've never gone, I know people who've done it 4 or 5 times, right? Yeah, that's might be a little crazy, but okay, so we'll close that. And then, but if I were to tell you how to go see the Burgess Shale, I would go to Stanley Glacier, Mount Stanley. And there's highway, oh, I forget that highway, the Banff-Windermere Highway. What's the number of that highway? 93, that's right. And you can see here, there's a big cirque. The cirque is kind of a jagged area where a glacier used to sit. And there's still a glacier up here, Stanley Glacier. And there's a hike that goes from the trailhead here all the way up this little river cut, all the way to the Burgess Shale and the Stanley Glacier. Talk about a worth it hike. And that is absolutely one of my favorite hikes in the mountains. But again, this isn't a trivial walk. We'll have a look at the mountain first. So we're going up between these 2 ridges. And here I like this view because you can see the Alden Stephen Cathedral Formation sandwich, which I think is Cathedral, Stephen, Alden. And what happens is when you get up to the head of the valley, you walk right up to the Stephen Formation up here. Yeah, I think I have my geological picks right there. And what the trail looks like is it's actually a pretty inviting trail. But the only problem with it is it's steep as heck. So it's like that almost the whole way. And it takes a normal person, and by normal, I mean normal but reasonably fit, probably about 3 hours to get up. And I think someone who's less fit, a lot longer, if not at all. And someone who's really fit, like we have Scott, myself, Stephen, we have a friend who's a PhD candidate here, Martin Schwanger, who runs up mountains like this for fun and would be up there in 45 minutes. And some of you are probably that good too. So, but yeah, this is a favorite hike. It's very accessible, and from a geological point of view, very worth doing. So here we have Cathedral Formation, Stephen Formation, and Alden Formation. But the deluxe part is right up in here. If you poke around long enough, you can actually find fossils. You can get guided tours here too. And the guided tour is just fine because they actually have a lockbox of fossils at the top of the trail that you can look at, right? So if you do go up here, I wouldn't go before June. There's usually still quite a bit of snow in the valley up until at least mid-May, maybe a little later, maybe up until the end of May. The Uber. You've done it 19 times, Stephen? What were you doing? Teaching field school. That'll do it. Oh my God. It's a great spot, right?
Yeah, can you hear me?
Oh yeah, just fine.
Yeah, it's a wonderful hike. It is a tough hike, but it's always quite inspiring the number of quite elderly people you see making their way up to Walcott's Quarry. So it's definitely doable, but you have to be patient and at one with the rocks to get up there.
19 times. That's some type of record if you're not a guide there.
Mm-hmm.
All right. And so that's the Stanley. And then over top of the Stanley Glacier area is the one area I'll recommend while we're here is the Mount Yamneska Alden hike, since we're here, because the Alden Formation, remember, is a Cambrian carbonate, and Cambrian carbonate suggests it's a biological sedimentary rock. Carbonates tend to be associated with reef buildups. In younger rocks, corals and things like that build up into reefs. In the Cambrian, it's more likely that there were other animals that were building the reefs up, like an animal we call archaeocyathid, which is kind of sponge-like. It's an organism. And anyway, Mount Yamneska is right on the front ranges. It's the first mountain you pass as you come from Calgary, so you can actually Calgary's off that direction somewhere over here. And the mountain is totally cool because it's actually Cambrian rock, and underneath this all is the Cretaceous Valley River Formation. So there's a big discontinuity right here, and that's a thrust fault. Does everyone know what a thrust fault is? You probably should remember from earlier classes, but I know there's a student or two without the prerequisite here. I'm waiting for a typed answer. Everyone's comfortable with thrust fault? It's when you push rock over other rock, and that's one way to get older rock on top of younger rock. It's probably the only way to get older rock on top of younger rock, actually. Okay, we're good. And then if we want to go up Mount Yamneska, I like this climb. It's not that hard, really. You go up this endless scree at the bottom, and that takes you about 2/3 of the way up, and then you're mostly scrambling on this carbonate rock, and you get a great view, right? That's the front ranges off there, and then off in that direction. You know, on a clear day, you can pretty much see Calgary. That's actually how awesome it is. But it's got to be a really, really clear day. And then I'll just point out that there's a couple ways out Mount Yamnuska, but you can see there's trails all over here. Some of these are goat trails, right? So you got to mind that. But I know that an easy way up Mount Yamnuska tends to be, yeah, right. Yeah, right up through the saddle here. You can come around the backside here, and then it's easy sledding, right? So that's the safe way, I think. Anyway, that's pretty good. Yeah, so Mount Yamnuska is super easy to get to. Day hike, no problem. There's some parking down at the bottom, just saying. Okay, now I'm gonna stop sharing. We'll go back to our notes here. Fantastic. The Burgess Shale and the Alden Formation, that's Mount Yamnuska with a much better picture. You can sure see now there, that's where the thrust fault is. And when I say thrust fault, for those of you who are a little rusty on your geology, it means this rock's been pushed this way and this rock was underneath it. We always show it like both were moving, but only the top. That's a relative movement, of course. That section, that little inset there, that's a piece of core that shows the limestone. And it's a little boring, but it shows you what the rock is like when you really see the rock. So it's a bit of drill core from the oil industry that was extracted from the Alden Formation. There's no oil and gas in the Alden Formation or the cathedral. And then this is that book Geological Wonders. They have that diagram, Massieu and Nelson, and that actually shows how the evolution of the Alden Formation. And what you have is this 3-step where you have originally horizontal, laterally continuous, like steno formations. Then you have the rock shortened, meaning squished together. A break in the rock develops and you ramp one set of strata over another. And then it's eroded later on. It's still being eroded today, right? And you get what's left of Mount Yamnuska, just a little sliver. Imagine how high those mountains really were at one point. There's a lot of rock that's been removed, right? Now I did post these Ordovician notes on E-class. Does everyone have them? Were you able to access them? Does anyone, let me rephrase that question. Does anyone need time to access the notes off of E-class? You have 10 seconds to answer. Okay, we're good. Well, Ordovician rocks in Western Canada, this could be the shortest lecture in the world if you wanted it to be, because at least in Alberta, there's really not much, okay? But let's go back to our, does anyone remember what we called these sequences? The name, there's a hint at the bottom of that slide, okay? Yeah, sloth sequences, nice work, okay. Good, Ashley, good, Dyson, love it. Sloth sequences, so these are super sequences. These are showing how the sea level rose and fell over time. So sea level is high here. I'm going to change colors. Sea level is, oh, that's a highlighter. That's no good. Let's try it. Sea level's high there. Sea level's low here, for example. So we're still in the Sauk sequence. We're going from the Cambrian, and it's a continuous increase in sea level until the lower part of the Ordovician, where sea level is about as high as it can get at the very beginning of the Ordovician. And you can see on the world behind me, as a consequence, oh, you'll have trouble seeing that. I have to stop sharing for you to see that. if you look at the screen behind me, you can see this is North America right there. Right there, that's North America. And by the time the Ordovician sea level rise, the South is at its acme, there's actually not much exposed land in North America. Most of it is under a shallow sea. And because it's under a shallow sea, there's actually extensive sedimentary rocks deposited in Western Canada, but they're not preserved, right? So this is what the landmass looks like. This is from the Ordovician of North America. Anyway, the Ordovician paleogeography shows that there's mostly marine carbonate deposition in shallow seas. And there's some emergent land, but look how small that continent really is. The emergent land is pretty small. There's some mountains to the southeast and whatnot. You'll notice also the continental position. North America is now in the northern hemisphere. It's drifted above the equator, and it's more or less oriented in the north-south relationship. In fact, it's moved quite a ways north. So that's a change. In the Cambrian, the lower part of the Cambrian, we're still farting around with the equator. So super cool, right? We have the marine basins, but the thing is, most of this isn't preserved. And if you really look at the preservation of Ordovician rocks, there's two main areas. One's in the Northwest Territories, where I haven't seen those rocks. I've never visited them. And the other is the Williston Basin. And believe it or not, you'll be pretty familiar with at least one Ordovician formation in the Williston Basin because you've seen it many, many times. But let's first start by thinking about a cross section, okay? And this is going to be a very simple cross section for the Western Canadian Sedimentary Basin. Let's first start with the disconformity or unconformity between the pre-Cambrian and then the Phanerozoic sedimentary fill. You'll remember that we have at least two wedges within the Precambrian of clastic, or at least sedimentary rocks. And these are the Windermere supergroup and the Purcell supergroup. So those are all underneath the fill. And then on top of that, of course, we have that Cambrian package that we've been talking about. So the Cambrian package kind of comes in two main units. There's a more of a lower Cambrian unit that to me includes the GOG. So that's the GOG business. And then above that, we get into the lowermost middle Cambrian, which includes the Cathedral and the Stephen, which we've drawn already. And then the Eldon. And then you've got a group of younger Cambrian rocks. These are separated somewhere in here by some type of unconformity. So there's an angular unconformity that cuts through these here. And then you go into the Ordovician, the upper Cambrian Ordovician unit. And the upper Cambrian stuff kind of includes that Arctomus, Lynx, Arctomus, Pica. I can't remember the order now. Lynx, Arctomus, Pica. And fundamentally, there's formations that are less commonly preserved in the mountains. I'm going to ignore those. And then they actually go into, there's disconformities in here, but they're relatively conformable to the Ordovician batch. So you kind of pass into Ordovician rocks above the Pica. And these really are I think the main rocks that you see, the one that you do see in Jasper, and you see in the Jasper Banff high, corridor, is the Survey Peak Formation. A carbonate, of course, because they all seem to be. Survey Peak Formation. And then if you go to Mount Robson, which is a little bit to the west, I think I'm trying to remember, it's the Glenogle Formation. And that's a little higher up in that area. And then on top of all this, you would have there's a Skokie Tipperary. I'm just going to call it Skokie and be done with. So there's a Skokie Formation. All of these are more or less carbonates that are Ordovician. So our Ordovician Cambrian break happens right around there. And I shouldn't be too misleading. We should continue our unconformity there. And then these lines basically unlap that. And then there's a big unconformity that cuts into all of the Ordovician stuff. And this is the problem, right? This unconformity actually does this as you go to the west. So there's really just slivers of the Ordovician rock preserved in the Western Canadian Sedimentary Basin. I'm no expert on the Ordovician. I'm the first to admit that. There's so little Ordovician outcrop in the main ranges and the front ranges, which is where I like to work, that I don't know maybe enough about it. And then going back to this kind of shows you what's left of Ordovician rocks in British Columbia and Alberta. There's these little areas here that are really where they're accessible. I'm sure there's great stories to tell about them. Williston Basin has quite a bit of Ordovician strata in it, and really the Ordovician itself, I think it's worth doing this once, and that is having some type of understanding of what the Western Canadian sediment, or the Williston Basin fill, looks like. The Williston Basin you really can think of as a bit of a bowl. That bowl goes from Saskatchewan to Manitoba, covers most of southern Saskatchewan, much of southwestern Manitoba, extends into Wyoming, the Dakotas, Oklahoma, I think. Yeah, it's big. It's a big, oh, maybe not Oklahoma, but into the Dakotas. So it's a big basin, and if you were to put it into some context, I think, I don't know the American states paleogeography very well, but if we thought of Alberta, Saskatchewan, easy to draw, hard to spell. Manitoba, you can tell who's not from Manitoba anyway. And the Williston Basin is like that, something like, oh, no, I put it way too far into Alberta. If it comes into Alberta, it just tickles it. It'd be something like that. Okay, so that's the fill. There's Cambrian fill. So the first unit is this Cambrian fill. It's largely speaking a terrestrial clastic unit. We'll call it sandstone. That oversimplifies it, but that's fine. It's the Deadwood Formation. And the Deadwood Formation is definitely a Cambrian. In some places it's shaly and is actually potentially a source rock, depending how deeply it's buried. And then you get on top of that, there's an unconformity. And the next unit is a unit that I'm very fond of, and it's called the Yeoman Formation. And it's part of what we call the Red River group. But importantly, it's carbonate and it's Ordovician. We'll just make sure we understand that it's carbonate here by putting in our limestone cross-hatching. And then on top of that, some Mississippian rocks. There's, well, oh no, we got to go into the Silurian and then the Devonian yet. I'm getting ahead of myself. So there are some Silurian rocks. I can't remember their names. And then Silurian, then there's some Devonian rocks. I think the most famous of those are the prairie salts, the Winnipegosis, so there's Devonian carbonates. And then this is, these are formations, Winnipegosis. Funny name. There's the prairie salt too, which we can put here. So there's an evaporite deposit that's out here too. And then above that is the Mississippian. That's kind of the next bit I wanted to get to. This way we won't have to do this again. The Mississippian starts out with a really important source rock, which is the Bakken Formation. One of the most important source rocks in North America. What is a source rock? Oh yeah, I've heard, you know what, Stephen, for the Great Hike through the full Ordovician sequence at Wilcox, I've got a picture of that right at the end of the slideshow. I agree. You know, I've never hiked up there. I'd like to do that one. Maybe when we get to that slide, you can just make a couple comments. So by the time we get to the Bakken Formation, we're in the Mississippian. And this is a source rock, meaning as it gets heated, there's enough organics in it that it releases oil and gas. It's a very oil-rich source rock. And so what we'll do is we'll actually give it, you know, it's common in geology that you use green to indicate that something's got crude oil in it, and you use red to indicate that something has gas in it. So the Bakken Formation definitely has oil and gas. And I have to say, so does the Yeoman Formation. There's oil fields in the Yeoman Formation that are very productive. There's some Devonian units that are super important in the Ordovician, in the Williston Basin itself, for sure. And then on top of all this is ultimately another major unconformity on top of the Mississippian stuff. First, we go to the carbonates of the Lodgepole Formation, and we'll put in unconformity. And on top of that unconformity, we can start to differentiate Pennsylvanian, Permian, Triassic. So now I'll just say Permian, Permo-Triassic, so a set of rocks that are that age, and a big section of Cretaceous above all this in Paleocene. So this is an inaccurate sketch of the Williston Basin fill. And I wanted to draw your attention first and foremost, though, to the Yeoman Formation, because it's the Ordovician unit, the Red River group. It's the one we're going to talk about. Green, where money's at, or at least that's what my well logging professor would say. Yeah, that's true. A lot of geologists will say that too. Yeah, no, for sure. I remember I used to work on oil sands as a geologist, and whenever you break off a piece of oil sand and smell the crude oil, people would go, "Oh, you can just smell the money. You can smell the money." But why am I so fetished about the Ordovician Yeoman Formation, because you've seen it all the way around you. Tyndall stone is a super common building stone that is used throughout Western Canada. There's buildings in Manitoba, Saskatchewan, Alberta, and British Columbia that are clad in Tyndall stones. I'm going to go back to the last slide. Shrink it a bit. How's that, Eisen? Oh, good. Okay, that's great. And so, yeah, it's this beautiful stone that has this funny mottled texture. So what is this mottled texture? Now, the first thing we can point out here is there are body fossils in here. This is a body. Ooh, that won't work. There are body fossils in here. This is some type of fossil, like Receptaculites, we call it. I think it's not that well preserved, so I'm not sure. But that's a skeleton, well preserved. What are these blebby things here? Any ideas? Burrows, absolutely. Yeah, the burrows. Now, here's something that's really cool about these burrows, though, is this is limestone. And this halo around the burrow, that's dolostone. And so what's happened is something compositionally about these fossil burrows was different, so that chemically the rock around the burrows was changed. And so you get this dolomitized zone around what we call a causative burrow, basically just a burrow. And the dolomitized zone makes for this really groovy mottling of the rock. Interestingly enough, when you look at this, where it's this is also, this rock is also forms an oil field in the subsurface called the Hummingbird oil field. And in that case, the burrows are so well dolomitized that they're actually where the oil and gas are preserved, which is pretty fantastically cool. So those are fossil burrows, and here's an example of a building on Capitol Boulevard, but you'll probably remember from 100 or 105 that there's actually buildings on campus, and we'll have a look at those. So I wanted to explain a little bit what that modeled appearance happens, and it's a good opportunity to explain something pretty fundamental about the fossil record, and that is, you can think of sediments, they're deposited as layers, right? And those layers over time build up. That's fine. And what happens is these sediments become colonized by animals. And in this case, those burrows seem to be worm burrows. So the worms are living in these vertical and branching tubes that are probably a bit more meanderous than I'm showing. And they have to connect to the sediment water interface because the worms need oxygen to breathe. And so oxygen, dissolved oxygen, comes from the seawater. So this is seawater here. And there'd be a range of burrows that would be present. Sometimes burrows aren't just simple branching units, but sometimes they twist and turn, and they ultimately connect. And over time, you get a lot of burrows then that are abandoned and stranded in the rock record. But you know what's interesting about this, and I don't expect you to ever have thought about this too much, but there's a chemical difference between the burrow and the sediment. For one thing, the sediment is just sediment, right? So this is disaerobic. It's probably no oxygen in the pore water. But the burrow linings are certainly oxidized. And so what you'd have here is you'd have this zone of oxygen distribution that's associated with the sediment water interface and associated with the burrows, an extension of the sediment water interface. Because of the presence of oxygen, and one other thing, that invertebrates that live in these burrows tend to support the burrows with mucus linings and whatnot, then because they support the burrows with mucus linings, they have a source of organic carbon that's associated with the margins of the burrow. And so there's compositional differences. And those compositional differences are twofold. One is the amount of organics that are there to rot. And when something rots, it tends to facilitate microbial activities, which tend to secrete different chemical compounds that can affect the composition of the rock locally. And the other thing is because there's a redox, now there's a redox, if you know what I mean, gradient, right? It's oxygenated here, but not oxygenated in the matrix. So no oxygen, lots of oxygen. And that means that there's an oxygen gradient in the burrow linings. And so there's mineral elements like that are dissolved in seawater, like calcium, magnesium, iron, that end up getting absorbed on the burrow linings. So that they get attracted to these oxygen gradients. And as such, then these burrows end up having a source of cations to make the magnesium required reaction of the conversion of limestone, which is CaCO3, to, and more correctly speaking, it's two calciums to 2 carbonates, and this gets converted to MgCa. I'm writing too quickly, sorry. MgCaCO3 twice, okay? And so these burrows facilitate this chemical reaction, and it results in these really cool fabrics of the sedimentary rock that are extraordinarily fossiliferous. Now, you can actually go visit some of these quarries in Manitoba, and you can actually see where the Tyndall stone is quarried, and here they're mining it for building blocks and slabs and whatnot. And they're using this great big saw that goes along on those rails as it goes. I've been there once, and I have to say, it's pretty cool. And they'll let you go through those rubble piles up here. If you go to if they'll take you into the mine, they'll let you go into the rubble piles and take home your favorite pieces, right? Not bad, not too shabby. So Tyndall stone, yeah, buildings in Edmonton that have them. Well, on campus, Torrey building right next to us has lots of Tyndall stone. St. Joe's College up on the other side of the bus stop is got a lot of beautiful Tyndall stone. Telus building, one of the newer buildings with Tyndall stone, and stairways from SAB to Quad. Yeah, and then these are the different examples. So here's a nice example with Maclarina. It's a giant snail. Okay, it's about, that one there's about 20 centimeters across. It's pretty big. And here's the gastropod hormatoma. Ooh, what preservation. See, that's the advantage of having a skeleton to get preserved, right? There's some types of ammonoids, and this is an ammonite that's at SAB. You can just walk around any building with this Tyndall limestone, and you'll find, so there's no such thing as Tyndall limestone without lots of beautiful fossils in. These are orthocones. These are kind of straightened nautiloids or straightened ammonoids. And these are the chambers that are associated with not only its growth, but they're associated with how the animal buoys and debuoys itself. So they think that these nautiloid orthocones could raise in the water column or sink in the water column, depending on how much gas, dissolved gas or water they could excavate from these chambers. And in fact, there's a little tube in the middle of these chambers that runs all the way down the center of this, and that's so they can actually evacuate, we think, bathymetrically evacuate some of these. They're literally the inventors of submarining. There's tabulate corals like Saphrodiphyllum, and they're a bit of a coral, round coral ball that's cut in half, right? Very nice. And there's tabulate corals. These are super cool. They look like little chains all linked together. Those are the what did they call them on the living chambers of corals. And so the animals lived colonially in these chains that were made of calcium carbonate, probably associated with reefs and patch reefs. And things like rugose coral. And a good example of a rugose coral is right here on the left. This is a rugose coral. And then over here in the middle is the tabulate coral. What is it? Calopeca. So that's Calopeca coral. Those are from Capitol Boulevard. Not that it matters. If you look around, it's always a fun exercise to go look and see what you can find in these trace fossils. There's Receptaculites, one I mentioned earlier from a worse photograph. And it's actually, Receptaculites is, we're not entirely sure what it represents in the rock record. Some people say it's like a stromatoporoid, which is kind of a spongy animal, but there's still stromatoporoids today. Receptaculites aren't exactly those. They don't seem to be corals. They don't seem to be stromatoporoids or sponges. So, you know, it's a little bit of a mystery. There's something that somewhere in between all those things, I guess. But very distinctive. And then, of course, there can be some beautiful Ordovician trilobites. That's from our own collection. That's okay. And a whole bunch, you know, or the Ordovician is the time of the grooviest trilobites, pretty much anyway. By the time you leave the Cambrian's kind of, you know, trilobites are just getting going. They don't have a lot of ornamentation as a rule and whatnot, but you can see some of these trilobites have a lot of character. This one here on the right, Colahalpeltis, is got these perhaps protective spines. People think the upper spines might have been protective. The lower spines, horizontal spines, might have been to help keep it up on top of sediment. Same with the lower one on the lower left, the Kettner apsis, which is a pretty popular trilobite. If you're a good collector of trilobites, some of these you can sell them. I've got a good friend who did his PhD at the U of A in the 90s when I was doing mine. And he still sells, he goes digging for and he buys and sells trilobites and he makes a tidy living doing it. But some paleontologists don't approve of that because, you know, a lot of people think making profit off of fossil materials is a little bit unethical because then you're denying it to the science, to the scientists who are interested in studying evolution and whatnot. I think that's more important with respect to dinosaur skeletons and whatnot. I think people are a bit more loosey-goosey about collecting trilobites, but you still can't do it in provincial parks or national parks. And strictly speaking in Alberta, any fossil collecting is, strictly speaking, illegal, okay? That's the truth of it. But they'll never, no one will ever fine you, as far as I know, for picking up invertebrate fossils outside of a national or provincial park. But do make sure you know the rules when you're going somewhere. And of course, brachiopods, and there's that Mount Wilson there. So Mount Wilson, where does that, I actually had a really cool image of Mount Wilson somewhere, Stephen. But where does that trail go? It comes from the south side on the right, right?
The trail up the pass starts on the east side of the highway, just south of the glacier. There's
So
actually there's a campground there, and the path starts just a little bit south of that.
oh, okay, so it's on the left side of the screen or the right? Because the right would be to the south, right?
Yeah, no, it's quite a ways left of here.
Or it's up, so it's up in here. This is the access area.
Yeah.
Oh, okay. All right. Yeah, it's supposed to be. I went on Google Earth and I looked at some of the sphere views of the hike up there. It looks gorgeous. It was really amazing, and I was pretty pleased. And then here's from Gad's book, where he actually gives the detailed Ordovician stratigraphy. And I just, in case you go there, but I'm going to go, do not memorize these formations. There's no purpose to it. And they're not even consistent with what I put further to the north, where I've greatly simplified it. And I think that's last slide. It is. Now, one thing I'll say is we're ending class a little early today, but there is an asynchronous video for you to watch, which is more about the evolution of life in the Paleozoic. Okay, so it's only 12-15 minutes. Well, I think it's worth watching, by the way. So go to that asynchronous video. That's on YouTube, so you can watch it. And then the other thing is, I've kind of narrowed in on the exam sketching question. I thought what I would do is, you know what, rather than discuss that now, I'll send you an email tonight or tomorrow morning. But that's the thing. Monday is actually a holiday, so we won't be having a lecture on Monday. We'll have a lecture Friday, but then we won't have a lecture Monday. And then the midterm is on Wednesday, and you have the whole 2-hour session on Wednesday to do the midterm. I'm going to find a way to email you the midterm. But does everybody have the ability to print off a midterm and photograph it and send it back? Yes or no? Okay. Don't have a printer. Tricky do. All right, Isam, I'm glad I asked then. I'll put more thought on this. I'll get back to you all tomorrow morning. I'm sticking with aspects of the crossword puzzle. I was going to do it online on eClass, but I don't, isn't it true that on eClass, the only easy way to do it is to, oh, okay, that's good to know. Like, you can't sketch on eClass or anything, can you, Isam? I've never written an eClass exam. But I mean, I did say it was going to be on eClass, right on my tablet and take a screenshot. Oh yeah, that'd be great. Yeah, okay. I mean, are you willing? I would writing on a tablet and taking a screenshot, if I'm give allowances for the fact that it's not necessarily easy to write on the tablet, be okay? I'll have to design my question that way then. Okay, I'll get back to you tomorrow on that then. That's words to think about, and I'll send an email that surveys the problem a little bit. Also, I gave pretty specific instructions about the PowerPoint assignment. I am going to prepare one PowerPoint slide as an example for you all. You won't have that till late next week, okay? So I'm going to encourage you all to go, or at least those of you who don't have any questions. Yeah, you bet. You're welcome, for sure. Lovely day, lovely day. I had the most fun I could possibly have. Stephen, how did you make that composite image of your face? It's both cool and freaky at the same time.
It's Picasso me.
Picasso. It is fantastic. Can't argue with that. Great. Okay.
Much better looking than the real me.
Hang on. Don't save. Oh, there you go. Okay.